Okay, so in 2009, the population of Hungary was approximated by this function, but it's actually approximating more than the population. It's showing you a trend, and it says what's it predicting for the year 2020. So the most important thing here is to make sure your t-value is correct. So if it's years since 2009 and we're talking about the year 2020, then it has to be t is 11. So we want p of 11, and that's 9.906. So you just crunch this out, and if you don't have a stupid calculator like I do here, then you'll actually get the right answer. Alright, so first of all, I'm going to just, out of my own curiosity, this is about 0.967 right there. I wanted to see how powerful that exponent was and how much it was going to yank down that. This is saying that the population is about going to lose a fraction of a percent every year, is what it's saying. So let's see, over the course of 11 years, we're going to lose about 3.5%, is what this is saying. So now, times 9.906 is going to give us 9.584, and this is in millions. And then the question is asking how fast in people per year does this population model predict that it will be, the population will be increasing or decreasing? Well, we already know the population is decreasing, so we're looking for a negative value to show up in our calculations. So I'm just going to draw myself a line here, so you know I'm going to use this blank space to start answering question B, just so that it shows up on the screen better. Okay, so P prime is all the stuff we had in P times natural log of 0.997, or P prime is natural log of 0.997 times 9.906 times 0.997 to the power of t. Now I wrote it both ways because, first of all, I expect as a student you're not going to know that it's legal to do that. So this is my way of telling you it's actually legal to do this, to put natural log of 0.997 times p. That's okay. But it's not a skill we expect you to master at this level. But if you feel comfortable doing it, go ahead and do it. Now I want to go ahead and say p prime of 11. And see, this is the reason I wrote it this way. Since we already just figured out p of 11, and we know that like all this stuff here is just going to be p of 11, I'm just going to copy it down. 9.584, and then I have to multiply it by something that's natural log of 0.997. And that's the problem I'm having with this crazy calculator. If I don't do this carefully, I'll get the wrong answer. So it's going to be negative 0.003. Okay, and then I'm going to have to multiply 9.584, and then I'll get negative 0.028. I'm going to put another 8 here, and that's million. But we don't talk about negative 0.0288 million people. I probably wouldn't take off on your exam if you did something like that, but the correct answer would be, 28,000, or do something like that. I could grab more digits out of here if I want, but they're not really, they're not, I don't have that much accuracy, but this is about right. If you said 29,000, that would be fine too. We do say 29,000 people, but we don't say 0.0288 million people. That's crazy. Okay. So, hopefully that made sense.